Hello my dear friends. So in the last class we discussed some important problems and as well as some basics regarding the complex numbers and how to convert those to a polar form as well as in rectangular form, and it's some problems regarding the RMS and average values, right? So let's continue the same now. Let's do some more problems so that you will get a good foundation. You will get a good foundation for those concepts. What exactly mean? Okay, let's do some more problems regarding the RMS and average value concept. Okay, write a question. I is equal to I0 plus I1 sine of omega t plus I2 sine of omega t. Find IRMS. So this is a typical question. No? Definitely this type of question will be asked in our examination. If it is an objective type model, definitely this question will be asked. Okay, this model, not this exactly, this model. If you have a current I, like definitely this will be instantaneous value, right? This will be instantaneous value, right? Because it is connected with the time now, so that will be I is equal to Im sin omega t like model, so that will be an instantaneous value. So if you have a current like this, I is equal to I0 plus I1 sin omega t plus I2 sin omega t, how can we find the RMS value? So by observing this equation, I is equal to I0 plus something, you may feel that this is something which is correspond to DC term, and these two terms now, and this is something connected to AC term. So for DC term, the RMS value is nothing but simply that value, right? Simply that value is the RMS value, because the definition of RMS value itself gives an idea that RMS value for an effective DC value, the DC value is the RMS value, no issues there. So what will be for that remaining terms? See, the remaining term will be in the nature of I is equal to Im sin omega t plus Im sin omega t like manner, right? So this I1 is nothing but Im. This is I2 is also like nothing but Im. So our resultant RMS will be IRMS equal to, you have to do in this way, which is nothing but I0 square plus I1 by root 2 the whole square. This is because IRMS is nothing but Im by root 2, right? Im is nothing but I1 here. So I1 by root 2 plus I2 divided by root 2 the whole square. This is the result of what? RMS value. This is called RMS value for this type of equation. Normally this is very usually seen in question papers like RRB, JE or SSC JE like examination. Definitely this question will be asked. This is very important. This is very important concept. Okay, let's do a problem, direct problem regarding that. Okay, please write a problem regarding that. Find the RMS value of phi of t is equal to 3 plus cos 4 cos 30. So this is you have to find. How can we find the RMS value? Simple. What is that? VRMS is nothing but, it contains a DC term, right? This is a DC term, and this is nothing but AC term, right? This is nothing but AC term. So whether it is in cosine terms or whether it is in sine term, this Im, no, suppose you have to convert this cos to sine also, you can simply cos omega t plus 90 will be equal to sine theta. There is no change in that. But you can change this cosine only to sine, but there is no change in this magnitude, right? Even if you convert this 4 cos 3t into sine term or sinusoidal waveform, you can only change this cos 3t into sine 3t plus 90, that's all. There is no change in magnitude, right? That means there is no change in Im, or see, it is Vm, right? So V of t is equal to Vm cos 3t, right? So there is no change in 4 here. So simply you can, for the RMS value of this waveform, like this is nothing but DC, no? So simply square of that DC value, simply square of that DC value, and remain this is Vm, no? So Vm by root 2, the whole square. Is it correct? Which is equal to nothing but root of 9 plus 16 by 2, which is nothing but root 70 volt. That is the answer. That is the answer. Is it clear? Is it clear? Okay. It's very simple problem, no? Very simple, but no, you have to think. You have to think the concept. You have to think the concept. So let's do another problem. Find the RMS value of the equation I of t is equal to 2 plus sin omega t plus 4 cos omega t. Okay, 4 cos omega t. How can we solve? How can we solve? Simple, right? Simple, right? This is nothing but DC and this is nothing but AC, right? Simple but AC. So how can we find the IRMS here? Simply IRMS here. IRMS is nothing but root of 2 square, that is DC square plus Vm sin omega t. So Im sin omega t, right? This is the form of I is equal to Im sin omega t. So IRMS is equal to Im by root 2, that is nothing but 3 by root 2 square plus again it is 4 by root 2 square. Im, it is for divided by root 2 is the IRMS for sinusoidal voltage. That is why. So which is nothing but root of 4 plus 9 by 2 plus 16 by 2. That is the root of, it is 8, right? 12 plus 9 by 2 is nothing but 24 plus 9 is nothing 33, right? So it is nothing but simply this much ampere, right? This much ampere. This is the IR. 16.5 ampere. Correct. Correct. That's simple. It was simple. The problem is okay. So let's go to the next problem. Let's go to next problem. Find the RMS value of the square wave. Find the RMS value of the square wave. Any square wave like this you can find for the RMS value. How can we find the RMS value? Simply, first of all, you have to write the equation because it is V, so it will be Vrms. You have, what is that? 1 by T integral 0 to T V of T square dt. Correct? That is nothing but root of 1 by C integral 0 T. What is V of T here? V of T is nothing but a constant, right, for up to T. So there is no need to complicate the thing by finding the equation on all. There is no equation, it's simply a constant value, no. So the equation will be nothing but V of T will be T. It is simply Vm. Vm square dt. So that will be equal to 1 by T. Vm square you can take outside, right? Integral 0 to t dt, which is nothing but Vm square divided by t. Integral dt is nothing but t from 0 to t. So it is nothing but Vm square by t into t. So this will be cancelled. This all contain root, right? This all contain root, right? So this will be equal to simply Vm. Vrms equal to Vm. Very, very important. So the RMS value of a square wave. Suppose you have any square wave, like suppose instead of this there may be some value, right? There may be some. Suppose this is Vm. In any question you may given like, this is also a square wave, no? Suppose you have some value, right? 10 volt here, and this is minus 10 volt here. This is also a square wave, right? This is also a square wave, no? So if you want to find the value of square wave, either you for manually by doing this calculation like structure, or you can go for the RMS value, like simply take the what Vm. Here it is 10. So 10 will be with the RMS value. Is it clear? Is it? What will be the average value here? What will be the average value of this square wave? It will be 0 because it is a symmetrical wave, because it contains both the positive and negative cycles equally. So that will be 0. That will be 0. So that's all about the average, our RMS value of a square wave. Okay. I hope it's very clear to you. I hope it's very clear to you. And let's do some more problems. It's a very big paper actually. That's why I'm so much confusing. Where is that? Let's check. See, this is my paper for calculation. Rough paper is there, no? So it's easily available, no? For 60 rupees, I think 60-70 bundles like you will get. So you can simply fold it and you can write. That is economical, right? In this corona season, economy is very trouble, no? That's why. So find the RMS value of the given waveform. See, another waveform is there. Okay, this is the waveform. How can we find the RMS value here? How can we find the RMS value? How can we find the RMS value here? See, this type of any waveform, no, in your examination, any waveform can be given. The thing you have to see the basic equation plus the equation of a given curve. That's all. Bas. You can solve for any value or any curve. You can solve for, no issues there. See, how can we solve this? You have to write the basic equation all the time. Okay, first you have to write the basic equation 1 by t. So in terms of omega t, no, so you can directly go for 1 by 1 by t, no issues there. 1 by t was equal to t. It is nothing but v of t the whole square d omega t. No issues there. Okay, that means here the total time period is nothing but pi, right? So from pi to again the wave is repeating, right? The wave start from here, it end here like this. Again small wave is started from here, end here. Again that bigger wave start on increasing. That means from here the wave is going to repeat. From here the wave is going to repeat means that is the time period, right? That is the time period. So they can use that equation. In this equation, the time period will be nothing but 1 by pi, right? 1 by pi, because from up to pi and after pi it is repeating again and again. So that is, we can write like 1 by pi, it is nothing but integral 0 to, you can see 0 to pi v of t the whole square dt, correct? D omega, okay, d omega t, not dt, actually e omega t. See, this v of t having two type of waveform. One waveform is from 0 to pi by 3 having a magnitude of 5, and another waveform is from pi by 3 to pi having a magnitude of 2. So by basic integration principle, this integration can be split up into 1 by pi is common, no, there is no changing that. I can give a bracket like this, and 0 to pi by 3, right? A waveform having a magnitude of 5, is it correct? 5 square d omega t, plus another waveform is from pi by 3 to pi having a magnitude of 2 d omega t. Is it correct or no? Because V RMS is nothing but 0 to t into V of t square, right? So that's why 5 square d omega t for one, and pi by 3 to pi 2 square d omega t for others, which is nothing but, listen carefully, it is 1 by pi, it's common, and see what it is, 25. It is 25 is common, no? I mean it is a constant, no? So you can take outside like 25 into d omega t is nothing but omega t, and having a value from 0 to pi by 3, plus this 4 is constant, no? So you can take outside, and omega t will be the integration result answer, that is 4 is taken outside. So integral simply d omega t means simply omega t, integral dt means simply t, no? Integral dt means simply t, no? Similarly, integral d omega t means with respect to omega t integration happens, no? With respect to omega t is the integration, so it will be omega t, right? So 4 into omega t, that is from pi by 3 to what, pi, again my whole bracket, okay? So that will be equal to root of, what is that, 1 by pi is again common, very big common, right? Very big common, so it can be taken outside. So that will be 25 into omega t, instead of omega t you can go for pi by 3 plus 4 into beta 4 into pi minus pi by 3, upper limit minus lower limit. Is correct or not? Is it correct or not? Is it correct or not? Correct. So what will be the answer? What will be the answer? I can rub here, I can rub here, I can rub here. I can write here, so it will become, what is the answer? VRMS will be equal to 1 by pi is very big here, so into 25 pi by 3, right? 25 pi by 3 plus 4 into pi minus pi by 3 is 3 pi, 3 pi minus pi is nothing but 2 pi by 3, right? So that will be equal to root of 1 by p. This common pi you can take outside, so pi you can take outside, 25 by 3 plus 8 by 3, right? So it will be equal to root of pi got cancelled, 1 by 3 can take outside, it is 33, right? So 3 and 3 get cancelled, root 11. That is the answer, root 11 volts. Root 11 volts is the answer. See, this needs only the basic integration skill, basic integration mathematical skill, but you need it, otherwise you can't move, you can't do a single problem like this. The problem is very easy actually, but you have to take care of the integration, you have to take care of the what is with respect to integration now, d omega t with respect to d omega t. So that type of things, that mathematical skill that you should have, otherwise this will be difficult to you. Okay, so let's go for the next one. I think it's very easy and it's so clear to you all, right? So let's go for next question. I will try to do maximum problems in the classroom itself, so that you will get a very good knowledge about the basics and how can you start a problem. That idea definitely I will give you. Rest is in your hand. The rest is in your hand definitely. You have to continuously practice. Otherwise, things will not be in your hand. So write a question. Find RMS value of triangular waveform. The waveform is having a value like this. How can we solve for such a question? How can we solve such a question? We have to find the RMS value of a triangular waveform. Okay, triangular waveform. How can we solve this? Simple. What is the equation for that? Our basic equation is needed here also. 1 by t integral 0 to t v of t square d omega t. Correct or wrong? Correct. Which is nothing but whole integral of 1 by t integral 0 to t. What is v of t here? V of t is nothing but the value of this waveform. I mean the equation value. I mean the equation of this curve. Let be theta. Then this will be a straight line which is passing through the origin. So definitely, what will be v of t? V of t will be, it is like y is equal to mx, right? Mx equation, right? Y is equal to mx. So m is nothing but here. What is the value of m here? What is the value of m here? M is nothing but tan theta. Tan theta is nothing but this term divided by this term. This term is nothing but Vm. I think it's already we done, no? I think this problem we have already done, no? Vm by t omega t, right? Omega t is that is what v of y of t, right? So just substitute in this equation, it will be definitely Vm square divided by t square into t omega t. So the result will be 1 by t integral 0 to t Vm square you can take outside, also divided by t square also you can take outside, right? T square also you can take outside, because Vm square by t square is a constant, right? Vm square by t square is a constant, right? So remaining terms will be simply what? Omega t square d omega t. Is it correct or wrong? Is it correct or wrong? This is nothing but here, right? Correct. Correct? Correct. So it will be omega t square d omega t, remaining term will be there. So that result will be a root of Vm square divided by t cube, right? Vm square by t cube, right? T cube into the integration will become omega t cube divided by 3 integration from 0 to t. This omega t with respect to omega t's integration happens here, which is nothing but root of, see the with respect to integration is very important. Sometimes it is simply with respect to t, so that you can simply with respect to t you can do, but here it is with respect to omega t, so changes please not changes, okay? So it will be simply Vm square by t cube, so it is nothing but beta instead of omega t directly you can t, not for this t you can substitute t. That is the very very important thing you have to know. Instead of this omega t combined you can apply that t instead of that omega t, not instead of that t, small t. Okay, so it will be t cube by 3. Correct or wrong? Correct or wrong? So this t cube and t cube can cancel, so the result will be simply Vm by root 3. This is very very important relation, because in many questions now, a different type of triangular waveform, sawtooth waveform, or sawtooth is type of triangular, no? Sawtooth is a type of triangular, no? Waveform you may given. You have to find the answer by simply looking at the question. No need to derive all this equation and find finally the value. It is simply Vm by root 3. It is nothing but Vm by root 3. So triangular means 3. You have to think triangular 3. So what is the RMS value of a triangular wave? Simply answer Vm by root 3. Whether it is 10 volt, whether it is 20 volt, whether it is 30 volt, anything, no, Vm is any value, I can see. By root 3 will give the RMS value, bas kadam kahani. Bas kadam kahani. Is it clear? Is it clear? Is it clear? So that is the answer of this question. Vm by root 3. Vm by root 3. I think it's very clear to you, right? Okay. So we'll go to the next question. See, you have a question like this. Find the RMS value. See, how can we find the RMS value of such question? How can we find the RMS value of such question? Can you do this? Can you do this? Can you do this? Can you do this? See, the answer is very simple. This is also a type of triangular wave, no? Folded in, this is also a triangular wave, no? Why there is a confusion? Why there is a confusion? This is a triangular wave, no similar value. So what will be the RMS value? Simply what? 100 by 3. No need to focus on what time is there, what time period is there, whether it is in omega t, whether it is in t, no need. You just need the value of Vm. The Vm is here, it is 100 volt. Vm here is 100 volt. So no need to worry about that. No need to worry at all. Simply you take the value of Vm by root 3 bus. You will get the RMS value. You will get the answer RMS value, because we derived the equation for a triangular wave, no? We already derived the equation for the RMS value of triangular wave. Then no issues there. No issues there. Is it clear? So that's all about. Okay. Let's do another problem. Let's do another problem. Let's do another problem. Again, find RMS value of how can we solve such a question? So how can we solve such a question? How can we solve such a question? Arey beta, this also a type of what? Triangular wave. This also a type of triangular wave dear. Triangular wave ds. This also a type of triangular wave ds. Then how can we solve? You no need to confuse and all. Simply take the peak value. What is that? Vm. So simply Vrms will be Vm by root 3. No need to calculate. No need to calculate. See how simplified the answer will be if you know this fundamental. If you know the RMS value of a single waveform, You derive it. You can apply to many waves, like you can apply to spike, you can apply to sawtooth waveform. You can apply to that also. Clear? And see one more question. See one more question. Suppose you have a waveform like how can we find the RMS value of this equation? See, in your university examinations and all, you may see like a question like this. You have to derive it for at least 2 pages now. Then you will find the answer. You will get the full marks. But this is competitive examination. No need to derive all the things. It will kill your time. Clear? So you have to know the basic. You have to apply your logic. This is also a triangular wave. This is also a triangular wave. A type of triangular wave, a type of triangular wave, similar wave is there. Triangular wave is nothing but a triangular shape. If you find a triangular shape in any wave form, that is a triangular wave. This is a triangular in shape, up to this, from here to here, up to here to here. This is a triangular shape. So everywhere we can see a triangular shape is repeating. It's repeating. So it is a triangular wave. Then what is the equation for the RMS value of triangular wave? Simply √3. No need to write, no need to derive, no need to focus about time period, no need to worry about whether it is omega t, whether it is on t, no need. How beautifully you can arrive at the answers. See, that is this circuit theory is it's a fantastic subject actually. It's a fantastic and it's very interesting subject. You have to know the basic. If you know the basic now, you can play with the equation, you can play with the question. You have to know the basics. Definitely some questions will be there which is very difficult, you have to think a lot. But after you did that, you feel that, oh my God, I did that problem. I have something. That power, that confidence level, that you will have now. That you will have at the time you complete your problem. And you find the answer which is exactly similar to the answer which is given in the question paper, or which is in the option, or which is in the book, anything, whatever, wherever. That confidence level, that level is need us. That level I need from yourself. Okay? So try. You will definitely boost your confidence level. Okay? Definitely boost your confidence. Okay, write another question. So you found a conclusion that make it in a box, okay? For triangular, sawtooth, reverse triangular, reverse sawtooth, RMS value will be Vm by √3 or Im by √3, whether it is in what voltage term or current term, like that. Make it in a box. its funda or trick. Okay, make it in a box. And let's do another question. Find the RMS value of half wave rectifier. Simply, what is the average value of half wave rectifier? This type question also you may expect in your examination. Simply find the RMS value of half wave rectifier. Okay, simply find the RMS value of half wave rectifier. You may find a question like this. How can we solve for such question? How can we solve for such question? How can we solve for such question? See, half wave you have to find, half wave rectifier output you have to find. Let be V of t, let be V of t. The output waveform will be like this. Is it correct or wrong? So 0 to pi there is will be output, to pi to 2 pi there will not be any output. So this is nothing but V is equal to Vm sin omega t. This is nothing but V is equal to Vm sin omega t. So this is the waveform. First step, you have to draw the waveform. You have to mark the angle. That is the first step. Then you can go for the RMS value. VRMS is nothing but, what is the value that? 1 by, what is the time period here? There is no change in that. This is the time period because after 2 pi the wave is repeating, right? 0 to pi the wave will be there. You know the half wave rectifier output, right? Half wave rectifier output. And pi to 2 pi there is nothing. 2 pi again the wave is repeating. So that it will be 1 by 2 pi integral 0 to 2 pi V of t square d omega t. Correct or wrong? Correct or wrong? It will be 1 by 2 pi, there is no change in that. You can't alter this 2 pi. But you can change these limits. It's from 0 to pi only waveform is exists now. 0 to pi only waveform exists, right? So it will be correct or not? So this will be sin square omega t d omega t, correct or wrong? So it will be Vm square you can take outside, right? Vm square you can take outside, or you can convert these sin square as 1 minus cos 2 omega t divided by 2. Correct or wrong? Correct or wrong, beta? Correct or wrong? Correct or wrong, my dears? Yes, correct. So VRMS will be equal to root of Vm square divided by 2 pi. There is no nothing changing there. Vm square divided by 2 pi. This 2 you can take outside here also. So into 2 also there. So let's start the integration. Let's start the integration. It will be, see, integral I can write like integral 0 to pi simply 0 to pi 1 minus cos 2 omega t. 1 minus cos 2 omega t d omega t. Correct or wrong? Correct or wrong? Let's integrate this separately. First you have to integrate this cos 2 omega. Let's find that. What is 0 to pi cos 2 omega t d omega? Let's find that first. It will be nothing but 0 to pi. So what is integral cos of 2 omega t? It is nothing but sin of 2 omega t divided by 2, right? 2 integral 0 to pi. So it will be sin pi, it's always 0, right? So integration will be 0. So no need to calculate the second part. That is the idea we get from that question. No need to calculate this cos 2 omega t part because it is what? Sin pi, the integration will become sin pi, that will be 0 all the time. So no need to consider these. We have to only consider for the first term. So which is nothing but Vm square divided by 4 pi, right? 4 pi, right? It is nothing but integral 1 d omega t is nothing but omega t from what is from 0 to pi. So it will become Vm square divided by 4 pi into pi. Pi got cancelled. Vm by 2. Vm by 2. Vm by 2. Is it correct or wrong? Is it correct or wrong? So that is the answer. So now you derive the equation for RMS value of half wave rectifier also. Half wave rectifier also. Now we are going to derive the equation for full wave rectifier also. Okay, what will be that? Let's see. Find the RMS value of full wave rectifier. You can change the question like, can you give it as a homework, right? Can you give it as a homework? Full wave rectifier, can you find that? Can you find that? Only thing is that I will explain, but you can do you do it in home, okay? I will say the trick, I will not trick actually, I will say the path. You have to find it, because time is very much consuming, right? Find the RMS value of full wave rectifier. Full wave rectifier. How can we solve that? How can we solve such a question? You write a question like this. Find the RMS value for full wave rectifier. Okay. I will say. Find the RMS value of full wave rectifier. Okay. Find the RMS value of full wave rectifier. How can we find that? This is nothing but full wave rectifier. 0 to pi will be there, pi to 2 pi will be there, 3 pi will be there, everything will be there. Simple, right? Simple, right? How can we solve for that? The thing here you have to notice is that Vrms is nothing but root of 1 by time period. Here it is the time period is what? Only pi. That is very important. There you can make a mistake. So the time period here is 1 pi only, because after pi the wave is repeating. After pi the wave is repeating. So the time period here is nothing but pi only. So 1 by pi, integral 0 to pi. Integral 0 to pi Vm sin omega t square d omega t. This is how you have to solve for the integration. This is how you have to solve for the integration. Okay. If you solve this integration, you will get an answer like Vm by root 2. Vrm is equal to Vm by root 2. This is the answer you will obtain. You try it in your home. Similar manner, right? Similar manner here. Same problem now. You have to do it by yourself. Okay. That will be the answer. Vrm is equal to Vm by root 2. Okay. Next question. The RMS value of half wave rectified a symmetrical square wave. Find the RMS value of half wave rectified symmetrical square wave current, square wave current of 2 ampere. Simply bus. This is the question. Find the RMS value of half wave rectified symmetrical square wave current of 2 ampere. So let's first find what is the symmetrical square wave means. So this is the symmetrical square wave. Equal positive and negative, that is the symmetrical square wave. Okay, let's draw beautifully. No, this is not, you might not feel like a square wave, like symmetrical square wave. So this is the symmetrical square wave. This is a symmetrical square wave. And symmetry will be there regarding positive and negative half cycles. So this is the waveform we have to find the RMS? No. Find the RMS value of half wave rectified. Half wave rectified means there will not be any negative half cycle. That is the meaning of half wave rectified. That is the meaning of half wave rectified beta half wave rectified. Clear? You have to find the RMS value of half wave rectified symmetrical square wave. Okay, symmetrical square wave current of 2 ampere means this is nothing but 2 ampere and this is nothing but I of t and this is nothing but omega t and this is nothing but pi, this is nothing but 2 pi, because half wave rectified means the angle is from pi to 2 pi. There is no change in that. Let's check the time. Let's check the time. Okay. Just find the RMS value here, but it's nothing but, how can we write that? IRMS will be equal to integral 1 by 2 pi. There is no change in time period. From here, this is the time period, right? Because the wave is repeating from here to here, no? So this is the time period. 1 by 2 pi is the time period, but out is from 0 to pi 2 square d omega t. Right or wrong? Right or wrong? So it will become 1 by 2 pi. There is no changing that, and 4 you can take outside. Integration is nothing from omega t is the integration and 0 to pi. So it will become 4 pi 2 pi into pi. Pi gets cancelled. 2 root 2 is the RMS value. Root 2 is the RMS value. Okay, time is there. I am continuously checking the time, right? So that is the answer. So that's all for today. So let's continue with new problems tomorrow. Okay, bye.